All right, it looks like I'm live. Today we are working on building a Matter Smart Lock with a Seed Studio microcontroller. And with my new and improved hand cam, you can actually really see what's going on here. So we're working with a Xiao ESP32C6, which is the latest and greatest of the ESP line. Now, I have been told that they're working on a ESP32C5, and I'm hoping to get an early sample of that soon. So, maybe we'll get to see it here on stream in a couple of weeks, maybe a month or two. I'm hoping. All right. So, let's grab the mag lock, wherever it's hiding. Mag lock, where are you? And its cable, too. Oh, there we go. Hiding under its own cable. So, make sure I'm not missing any chat messages. Hello, chat! So, what we're going to do is use this lovely braided cloth wire to carry our 12-volt signal up the wall to this device. This is our very simple 2-wire 12-volt magnetic lock. And it just mates with a steel plate you bolt to whatever you don't want to move when the lock's on. It has 180 pounds of force in this direction, and this one essentially. So it should hold the sliding door shut from the cat and dog, as that's the purpose of this device. Turn my speakers down a bit so I don't deafen myself. All right. So I'm going to start by soldering the mag lock to its cable. There we go. So I have to connect this to this. Kind of a big to small situation here, but it's for aesthetics, and extra copper means I can carry more current. I don't need it, but hey, it'll still work. I'll just strip off a good 1/4 inch, maybe 10 mil of material. Yeah, that's about good. I essentially want the same length as the wire I'm attaching to, so that one's good. But that one's long, so we'll give it a haircut into some sort of container so I don't have little shards of metal on my desk. So now those are an appropriate length. And I'll just weigh the cord down with the roll of solder there. And we need a bit of flux. Look how gross that old flux is. I should really buy some new flux. Hello, Finn Gamer. Lovely to see you. Thanks for joining. I'm making a Matter Smart Lock inside a Decora wall switch today. So this is the switch, and then I've got the brains and this is a a buck converter that takes a 12 volt and puts it down to 5 for the microcontroller. I've got a couple of resistors for LEDs on here, and then in the body of the switch, I've drilled in these 3mm LEDs in the two corners, which light up either this half, or this half of the switch. Yeah, I try to do morning and evening streams so that more people can catch them. So, yay! All right, let's warm up the soldering iron, which only takes a few seconds. This is a SaneSmart TS100. I'm not sponsored by them. I just really like this soldering iron. These are amazing. You can even reprogram them with different firmware with that USB port on the back. So, well, I've touched my heat shrink. Hopefully that doesn't come back and bite me later. Okay. So first we got to prep the wires by applying some flux to the ends. And I need something I don't care about to do that with, like an old zip tie piece or something, or could use the proper tool, a flux brush. I'll just get a tiny bit. That's a huge bit. So there's a tiny bit of flux on each of those wires now. And we're gonna get some solder onto there. So each of these wires is going to get tinned with solder. Let's zoom in. Ah, that's gross. Let's turn on a fume extractor. There's now a crosswind across my desk. Excellent. All the smoke's going straight in there. Let's get this pointed down a little more. And I'm just going to clean whatever's smoking off the tip here. All right, that's better. Those ones were already tinned. I don't know what I'm doing. So let's get the brown wire. Brown and blue are a common color code. Brown will be your hot wire, blue will be your neutral or ground. Right, so I have the heat shrink on. I just need to actually tie the wires together. Line them up side by side. That gives us a nice, solid connection. I'll have to fix the zoom. Back it to where we can see what I'm doing. All right, so that's nice and strong now. I'm just going to do one more violent tug test on it, so that's not going to break on me. I want to see if I can actually get the cloth to be under the heat shrink tube, because that's going to look a lot nicer. Yeah, so this little clamp is one of the first things I printed, and it's really cool because it's like a print in place design, so you don't have to assemble it or anything. And it would actually be impossible to assemble this because the parts can't move past each other. So it's super, super duper helpful. I found it on printables, and yeah. Even made it a PLA, it's been super useful. Alright. Let's just get a grip. And then try to work the cloth back up the wires. Now I need to get the cloth here, I have to get it wet and twist it down against the wire to get it under the heat shrink, so we will use the alternate option of giving it a haircut. Because the goal here is to get the heat shrink to grip the cloth so that it looks nice. But that means sliding the cloth braid back up the wire that I pushed down earlier. Which I can feel it's working. This is going in someone's home, so it has to look nice. It's not just something to sit on the shelf or a curiosity. This is going to make it easier to let the dogs and cats in and out than a mechanical lock that freezes up in the winter. Ooh, we're pretty brutally bending our solders here, but that's alright. They seem to be standing strong. blue one down a little more. Those look like they're in the range. We need them in. Let's just slide this up. Alright, well, that didn't work. We're going to throw some cloth tape on it to hide our defects at the end. Let's fire up the hot air gun over here. We're going to want like 200 Celsius because we're just doing tape. No, I'm doing this for free for a friend. It would be nice to earn money off these skills, but not yet. Not yet. Alright, now I'm going to protect this whole area with a wrap of cloth tape. I just have to go get the tape. Alright. Hi, wife. Welcome to the stream. Love you. Alright, so we're using this neat cloth textured tape. We're just going to take like 6 inches of it, and we will snip it. I'm going to put it between my legs here. And now we have our strip. Pop this out of the vise. And we're going to do a slight angle. Now, this makes me want white cloth tape. And you may wonder, why? You're using black wires. Well, let me show you. I also have really nice white wire, so white cloth tape would really go with it well. We're down as far as we need to go, so I'm just going to tightly wrap this around the same spot a few times. So now our mag lock is on a 2-meter cable. We need to get some screw terminals going on our board. Crotch cam deactivated. Yeah, there is supposed to be music. Alright, you should have music now. That's better. I have the monitoring headphones on the floor so I can check the music from time to time now. We're playing a random playlist of techno, dubstep, royalty-free music, because I want music, but I don't want to get in trouble. So, better than nothing. Actually, I kind of like some of it. Alright. Yeah, so let's start by taping up this end with some cloth tape so these don't fray too much as we work. This is the end of my tape, my friend. Come on, tape. Be my friend. Only need a little bit. There is a method behind my madness here. Yep. Trying to keep it pretty. I'm doing this strip in 2 stages. I gently close once, rotate, and then pull, because otherwise it doesn't strip nicely. I don't know. Get that pinch down in there. Right. Plug the soldering iron back in. I like to plug it in when I need it, because otherwise it'll be sitting around and I'll burn myself on it. And it only takes a few seconds to warm up. It also keeps the tip from getting all oxidized and gross, because it's not sitting there just burning away. That's the other thing. It's ready. That makes this such a good iron. Alright. Let's be smart and apply some flux. The other great thing is you can just set it across your coffee cup and it's not going anywhere. Just don't drip solder in your coffee. I hear lead is bad for health. Yeah, they're on for like $69 on some residual Black Friday sales. If you're really into soldering, I would advise getting one of these. It's actually the advice I gave to someone on Discord yesterday. They're starting into electronics, and if you're going to be doing fine soldering on the back of boards, this is really good. The fume extractor is definitely doing its job. I can see the smoke just going that way instead of much primo. I have had to solder with a lighter before, so good on you for the MacGyver spirit. Do it with what you got. Alright, these wires need to be tinned up as well while we have the soldering iron on. I'm just going to dip the tips directly in the flux. There we go, they all got a tiny bit of flux on them. They're all fluxed up! We're going to wipe the excess goo off the tip of the iron. With several layers of cloth between you and the heat. Maybe don't use this technique. I will put it in the chat in a moment. There are also tons of clones of it. The clones are great too. We got those done. So now we need to get wires into the board. Oh, we got one more board component to put on. This is going to go here. And it's going to provide the screw input terminal for the 12 volt to the device from the wall. That way you can just take a regular 12 volt wall wart, cut the plug off, and screw it in. We got to do the wires first. Oh, there's another one that needs tinning. I'm going to cheat and put the flux on the solder. Right. Now we're just going to do a little cleanup around the ends of these wires to get rid of the excess flux. That brown stuff. Yeah. Cleaning that stuff off will prevent it from getting all gross later. Hey, good morning, Kaon. I hope your work is going well today and continues to be profitably busy. Alright, so this is the 12 volt ground in, and we're just going to jump it over the device to where the pins for the screw connector will land. we go. Now I just have to solder that guy. Let's get this into a clamp. Oh, Disc-kun! Hello, Disc-kun! Yeah, the discs for the not Super Famicom, the original Famicom disc system had a really cool copy protection thing. Embedded in the surface of the disc, just like in the surface of this. See, there's this AE here? They had the full word Nintendo along the bottom of the disc, and there was a thing that would sit down into the Nintendo letters, and if it didn't fit right, the disc wasn't right, and it wouldn't play it as a copy protection mechanism. Now, the problem here is I can't let go of this wire or I'll have to push it back through the board, and that was awkward. So, we'll just go one-handed on everything else while we do that. I'm over here getting a grip. And there we go. A shout out for my good buddy Kaon. He is an awesome Nintendo streamer. And I say Nintendo streamer because he is on a quest to beat every NES game ever, and he's like 200 and something games in. Really impressive. I believe he also does something similar to what I do at work, but I don't know, it's a secret. Alright. The wire seems to just be chilling for me, so... turn on the iron. And we're just waiting for it to heat up. Alright. Let's show that connection. So the new connection is that one right there. And you can actually see that it's a nice little pyramid on there. So I think that's a good connection, and we can move on to the next step. So hopefully I left room for this guy to fit on. I didn't. Oh. It has to sit over at the very edge of the board, which is a little crowded, but what can you do? You can see its pins are coming through there, and we're just going to tack it in place. Flip it right over. Let's gravity help. Must remember to turn the iron on after unplugging it and plugging it back in. Nice! Wireless stuff is super fun. What radio technology are you using? Right. That one could use a tiny bit more. Pretty good looking solders on the back here, but it's dirty, so we need some alcohol. Much like me, well, much like the dwarves in Dwarf Fortress, to get through the working day, I require alcohol, though not to drink. We'll use this nice fresh bottle my wife picked up for me at the drugstore. What do we got? Alcohol, isopropylic, 99%. Apparently I have French isopropyl alcohol. Oh, it's English on this side. Welcome to a bilingual country. Cool. Yeah, that reminds me of Nordic's enhanced shock burst protocol. I'll have to read up on it later, because seems cool. Yeah, us retro gamers have never heard of Capcom. That's really effing cool, Finn. Okay, so what do I need? I need the trigger line from the relay. So I need these wires. Fortunately, on the back, it's labeled ground, VCC, not connected, and signal. So we're going to clip the white wire. Because we know it's not used, and I don't want to solder something accidentally. That'd be dumb. Throw the little tip of the wire in the trash. Hey, Nettis, welcome in. Good to see you, bud. Okay. That's all trimmed down. So, I think I'm going to give this 3.3 in ground, which is right over here. So, we're just going to have to move some of the wires out of the way for a bit. Made myself a little puzzle here. This track is annoying me. Alright, now I have access to these two holes, or these two holes to put these wires in. So let's make our lives easier and just detach the cable. They strip to different lengths, and that's going to be a problem for tidiness. So, let's fix that. Now they're similar strip lengths, so it's a lot easier to get them evenly into the board. Have a great lurk count. Thank you so much. So now they sit in the board a lot more evenly. I just have to get them to want to stay there while I solder them. Put the soldering iron back in for the trillionth time. Yeah, I have been using side cutters to finely strip wires because I've stripped probably 15,000 wires over my recent career, last 10 years. Building custom electric vehicles and giant battery packs from scratch meant a lot of like voltage check harnesses and doing soldering upside down under a car, all kinds of crazy stuff. So yeah, just being able to do it with these two tools makes you a lot more mobile. We even had a like the standard drill battery pack and then a cable that would hook up to it. Really awesome. Because it'll take like 19 to 24 volts and run on that. So yeah, we had battery-powered precision soldering irons wherever we went, under a vehicle or whatever. I am working on a maglock controller. So here's my mag lock on my 2.5 meter cable. This has an ESP32C6 on the back, and we're going to use this Grove relay to drive this from a 12 volts wall supply. This will allow my friend's sliding door to be magnetically locked, because the mechanical locks for those things suck. Like, they break, they freeze. But a big mag lock up at the top, the sliding mechanism, it's not going to break. Anyway, let's proceed getting the power wires soldered in place. We're at temperature. Let's give the tip a little clean. I'm pinning the board with one finger and feeding solder with the other two. Of course, my hands are shaky, so that's not helping, but... Well, one of them looked okay. But they both managed to pull out of the board while I was doing that, so... Alright, so that's pushed nicely against the surface of the board, but God, does the bottom look terrible. Now, no, get in there, get in there. All right, through we go. Okay, so it needs a little trimming, but it should work. Yeah, I was mentioning earlier, this morning I got notice that I'm very likely getting a sample of an ESP32C5, which I don't even know what the C5 does. I'm gonna have to look it up, but I said, heck yes, please send me one. I actually got invited to an semi-official Seed Studio like advisory committee because I use their products so much. Me and two other engineering nerds are in there giving them new ideas for their next gen products. So, and they're sending us samples. Yeah, it has Wi-Fi 6 and it has like a Zigbee thread radio and Bluetooth. But a lot of examples in code don't work for it yet, but I'm not afraid of that. I'll figure it out. Okay, so power input's on. Relay power is in. We just need the relay signal line over here. Which I've designated for D0 on the microcontroller, which is this very first pin. And of course, there's some wiring in the way that we'll have to nudge out of the way temporarily. Working on this yellow wire right now. Let's get you a better view. What do I use for code? Everything. The C6, I have to use ESP IDF for matter about, so we're going to be screwing around getting that working in Linux later, because none of the examples are set up to work in Windows, so WSL it is, but that's right on this machine, so no big deal. And if not, we will build an entire second Linux box on stream just to deal with it, because I am unstoppable. But to answer your question, I prefer VS Code if I can use it. Alright, nice little pyramid. Got a wire tip in trash. I already gave those guys their haircuts. And let's just tuck that excess wire away. Alright, that's... we're missing a couple more wires. So we've got our relay control, our two LEDs, but we need to detect the switch state. I could not find... Well, the tutorial I'm following from Seed only covers Mac OS and Linux, so... Alright, I will be right back. I need to hit the washroom. Right. Let's catch up on the chat. Fair enough, yeah. So I still use a combination of VS Code and Arduino IDE. I write the code in VS Code while it's still open in Arduino IDE, and then I just compile and upload using the IDE. It's still slow, but that way at least I get AI assistance while I'm coding, which is much faster than doing it all by hand. Alright. Yeah, so let's get out the multimeter and figure out which of these contacts goes to which, and when you flip the switch, which comes on. So to do that, I'm just going to put this in continuity mode. And check the contacts. So, no contact currently. So now there's contact. Cool. So essentially, I have to put wires to these two. One to hot and, sorry, 1 to 3.3 volt, and the other one goes to an input. Alright, let's get some wire. We'll go yellow and black for these. I have different strippers. No. Fine, I'll do them one. Alright. Next track. Well, that's way more than I wanted stripped, but actually that's just the right amount. I want to make a good loop, so let's grab this pencil. There's one loop. Screwdriver. All right. Fish this in here. Make sure. Close the loop up a bit. Throw the screwdriver across the room, because that's just what we do. Right. I need to flip that over. Alright, so we'll strip the other end. And we're going to do a continuity test to make sure I didn't like pinch the plastic instead of the wire. So we're in continuity mode. We got continuity on the wire. Perfect. Turn that off so it doesn't freak out. And do the same for our black one. Okay, those are good. Now, where do they have to go? So, let's bring this to the other side of the board. At most, we need that much wire, so let's strip a little extra. This is old Bell phone wire. Oh, hat enable. Enabling hat. Pokey toast. Pokey toast needs more coffee, but I can wait a few minutes. I want to finish getting these wires done. Oh, the YouTube stream is dead. It's still upset about it. Hey, Dom Retro, good to see you. All right. Oh, that sucks. YouTube just won't work for today. Focus. Focus on the device you're making, not on the technical problems you're having. All right. And this wire needs to get trimmed down to about there. And we'll just give it to the cheap stripper. Come on, stripper. There are much better versions of this stripper tool than I have. Alright, let's get this guy poked up in the right spot. Right, that's where I want it. Alright, now let's get these pins all done up. And check chat, make sure nobody's asked any questions. Alright, the tip of this is all gooey. Where is my wad of towel for cleaning the tip? Ew, it's gross. Let's just fold it over the other way. Nice and clean again. Well, that looks good. We'll grip the excess wire so it doesn't go flying and just trim it off. This one's a little more delicate because there's a wire in the way. Maybe I can do something about that. Nope, it's just going to be in the way. Good enough. Accidentally sealed off one of the holes, but that won't hurt anything. Alright, I think that's the completed wiring. So before we try to run Matter on this, we're just going to do a quick Arduino firmware to test that we can run the lights, we can see the switch, and we can turn on the relay. There's our there's the complete driver assembly all in one spot. So this is a wall box, and this sucker has to fit in here. Just like this. So it all fits in. I just need to do some insulation tape around stuff so it doesn't like short out when you jam it in there. But this is going to be a low voltage only wall box, so no 110 in here, just the 12 volt and the 5 volt and the 3 volt. Just putting away the toxic pot of flux with the lovely lung damage warning, which is why we've been running this fan I can turn off now. I'm going to put this in here so it doesn't slide around the desk so much. Go. So, pretty boring right now. Let's get some code on it. Once I get room to put my arms in front of my keyboard again. And yeah, who knew that breathing in something that is so acidic it burns the oxide off metals would be bad for the inside of your lungs? Oh, right, most people probably. Alright, I need to refill this coffee. I will be right back. Okay, so we're going to see if we can find some LEDC code I've already written. Yeah, it'll probably show up in Arduino IDE. Hello, ceiling. Oh no. Camera's trying to make its escape. Camera can give you that toast. The sideways toast. I just don't know what to do with this extra space up here. I don't think the camera's right for this scene. Yeah. We got the manual over there. We got the ID over here. But we don't need the manual at. Hey, there's the ESP Now stuff Kaon mentioned earlier. That's cool. Don't believe Netist. Alright, we're looking for something called LEDC. Probably install the LEDC library, maybe? Nope. Probably just in the examples. I just need to be patient. So, I've actually doubled up. There is a ventilator up there in the ceiling, and one sitting under my desk that I bring up when I'm actually soldering, so... Lung health's kind of important, especially since this is a basement, and normally it would be, like, poor air quality down here without it. So... And it tells me where the example is, so... It'll be in the peripherals section. Wait. Yeah, there's supposed to be... That song's distracting. Yeah, the fans in this room are stupid expensive. Like, that's a $300 bath fan compared to like a $30 one. No, wait, only $200, but still, it's 3-speed DC instead of an AC fan, so it's a lot quieter. And then the other one is like the official Weller solder extractor, so it was like $95 at a big electronics store down in Cambridge called Xiao. There is just so much stuff in here. So I'm just gonna cheat, I guess. What do we got? I have him. I see you have a cat wrapped in a blanket. I do not currently desire a cat.
Okay.
I mean, you can show people cat. Yeah, how could an engineering nerd get... Yeah, there's a lot of atheism in the engineering community for some reason. Okay, where were we? ESP32. Oh, it'll probably be actually under that because it's a specific ESP32 driver. The Tway touch timer time reset reason interesting. No, none of that is what I want. We don't want sound. So I'm putting Claude to work here. Because I can't find the sample. So I learned earlier that there's a difference in perspective between people making AI and people using AI. Some of the people making it believe that they'll be able to combine themselves with AI to become a godlike creature, but horrifying. We'll see how that goes. Let's see. Does this code build? Okay, alright. So the C5 board definition exists, but you can't buy them. As far as I know. Oh, man. I wasn't paying attention for just a second. Creamy Mountain Tupidi. What a bot name. Yeah, I felt like a god already in my workshop before AI. It's definitely helped me do things faster. Alright, did that compile? I think it did. No, it is compiling. Let's get this camera pointed at. Finish having a fight with my camera stand here. Alright, camera. Too much dubstep talking. Hopefully I'll remember where I put that lock later. Hey, it would be cool to see if people showed up. Okay. So now we're actually going to put the code on there and see what happens. Hopefully we get a light show. waiting for... Oh. Okay. Well, one of them works. Wonder why only one of them works. Let's use the actual macros for the board. Duh. My fault for letting the AI code it. Now that's what I'm talking about. So, hardware for the LEDs is proven. And it wants to make a README file. Oh well. Let me add the ego. Alright, that should write the rest of the code for the application. So, let me find what I asked it. So, this is the full prompt that should get the prototyping test software done. Oh no. Average stream bitrate too high. What does that mean? You may have to, like, click remove embed or something. It's a little annoyed because it's not an Arduino ID and it doesn't know what's going on. But that's fine. It's getting the job done. Like, yeah, I'm done. I'm gonna update the documentation. And we can see Arduino IDs already showing the edits to the file. Well, it built. I should have actually deployed it. Alright, it's generating the image, and... So that red light is the relay turning on. Pretty freaking cool. Alright, so there's our base dumb firmware for the unit, although I need to adjust how the lights work, but that's it. That's the machine. I gotta take a whiz. Okay, we're back again. Nice. I killed the coffee again. I should make a second pot next time I take a break. Okay. Let's turn on the lights and hook this up to the actual maglock. And well, hold on. Let's finish fixing the light. So we're just going to do this by hand. Well, let's try talking to it over serial. Maybe it just needs configuration. It's got help! Oh, let's ask it for help. Help me! Well, let's relay off. That work? Did you pay the points? Somebody paid the points! And suddenly there is a slightly damp cat here for petting.
He was in the snow.
Hello, snow buddy. Hello, buddy. I'll put you in hug position. Nope, you're out of here. You want to be gone? Cool. Well, we got a little bit of pet the kitty out of it. That was Cole. I love Cole. He is my favorite void beast. We're even looking at the... Okay. Let's request status from it. And oh yeah, somebody's gonna bring me the razor blade with fur. I can't wait. Demon Mountain. Get it. How do I open it from the outside? Huh? Oh, you don't. Actually, the whole idea is this is a Matter smart device that connects over Wi-Fi to your home network, and then you can control it through Google Home or Apple or Home Assistant, which makes it even more cooler. So we're just writing base firmware to make sure all the hardware works, and then we're going to add these functions into the Matter smart lock code to make a Matter smart lock. Yeah, the whole thing with the cooldown on the cat is I didn't want to have to be running all over the house more than once every half hour. But I'm sure if my son's listening, he can bring down the other cat for free for you. So we're in software override mode, so the switch doesn't do anything. We'll go back to relay auto. Now the switch does something again. Very cool. I'll show a practical example of what a relay does. So we're just gonna get out the meter and put it in continuity mode again. And I'll hit the switch. So I have my probes pushed down into the two contacts on the relay. And I'm just gonna hit the switch. And you can hear it makes a connection when the remote signal's on. That's how a relay works. Little signal turns on a big signal switch. I see kitty cat.
Sweetie kitten. Sweetest of the sweet kittens. Oh.
Thank you for sitting through the ads. Here is our other kitten. She very much wants to get away from me right now. Oh. Is that you? Oh. 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 Wow, she even left a wispy hair in the air. Okay. Almost a cooperative kitty. I thought I was going blind. It was just cat hair. Okay, so... Yeah, I got attacked by cat wispies. Alright. I swear I still see them flying around. Alright, so we're going to have the hardware switch state change, put it back in auto mode. We're going to have the LEDs completely turn off when, I ask it to turn off. Instead of just kind of getting dimmer. Like, we do have a brightness variation, but I want it off. And I'm lazy. See you later, Finn. Thank you so much for hanging out today. Request for lunch. Coffee, a sandwich, maybe. We need more coffee. Right. And it's on to updating the documentation, so we will flash the updated firmware with the changes I requested. Oh, it turned off because it's being flashed. Where is it setting the brightness? That's just... yeah. It's being stupid and trying to use digital off when it needs to be PWMing 0 hertz. I forgot to tell it they were active low. So it's actually turning them up instead of turning them off. That explains what's going on. Also, based on the spec sheets of the LEDs, I'm going to have to make the green one half as bright as the blue one for them to be equally bright. Because, yeah, the green is exactly... so... so the blue is 3,000 to 4,000 MCD, which is like micro candle power or something. Whereas the green are 6,000 to 8,000 for the same amount of power. Twice the light for same price? But maybe that's because our eyes are more sensitive to green and it's just easier to make green. Now one of the LEDs should turn off. Well, all three of them should turn off briefly in a moment. While it loads the code. Hey, now only the blue is on while the lock is engaged. Green's on when the door's open. That's what I wanted. And we're still talking to it over serial, so So we've got our brightness set to 5% now. But to make them equal, we're going to set one of them to double the brightness of the other. I don't know if that made a difference. I think LED 1 is actually the green one. Nope, green is LED 2. So we'll set that to 10. We'll set LED 1 to 20. Equal subtle amount of light. It should be fading, but it's fading so slow I can't tell. I think I have to turn the blink on. There we go. That was the meter getting upset because I wasn't playing with it and I left it powered on. Cool. Alright, I'm going to stick the code for this in a Git repo. That was weird. The lights on my wall just freaked out. I think we had a power blip. So this is a Leviton light switch that's been hacked to have a microcontroller and a relay attached. When you press the switch, the relay changes state. This is meant to drive this big old magnetic lock here. 180-pound bolt force. Should hold a sliding door in place to keep the dog from opening it. This device does fail safe in a power outage. It unlocks. Nothing I can do about it, which is good because, yeah. I have incoming deliciousness.
We ran out of hot coffee, so I made you instant coffee because
Thank you. I need to continue making our new repo. I'm just telling it to attach the repo I just created on GitHub. It's setting up a git ignore file. Making the initial commit, and then it's going to plan how I'm going to get the Matter Smart Lock integration in here without resorting to switching over to ESP IDF. Earlier, if I didn't know what I was doing, I never would have figured out why don't the LEDs turn off when I ask it to turn off. It would have taken like 10 cycles before the AI figured out, hey, maybe it's backwards. Oh, Claude! Co-authored by you? It's true. Actually, you did most of the coding. Alright, yeah, branch main, push, origin main, sure. I have to manually authorize its access to GitHub, but that's good. So I've essentially said, hey, we've written the base firmware, integrate this as a Matter Smart Lock. Let's see what we get. Otherwise, I'm going to spend a couple hours going through the tutorial. We're going to get there either way, but why not use the tools at hand? Some people hate AI. I hate AI when it's used wrong for, like, creative purposes and stuff. But if you're making memes to make people laugh, use AI. If you're making commercial art to make a video game, hire a goddamn artist. and let them use AI on their style of art because they produced it. But you need both, because right now, it's just not good enough. Thank you for attending my rant. I think right now it's stuck because I've given it a hard problem and not enough information. I want to stop it, but I also don't. Might just pull it off. And if it does, then I'll have a example I can share with people on the internet that works. Who knows if it's secure, but that's why there's 1,000 eyes on it in an open source project. So people can check. Holy crap, we're to the README stage already. I think I may have to borrow someone else's phone to complete this, but... because my phone is right here. Hello. That's why you can read the text on the microcontroller. Because DroidCam is amazing. That's close to accurate, but these are actually 22 ohm. Let's read through this and make sure. Ah, so there are... It's got configuration for Arduino ID to make it work right. That's slick. So we need to go tools board, yep. Tools partition scheme. Well, I have to select the board. And pay attention to chat once in a while, too. Alright, so there's the board selected. Now I have my tools, and there should be... partition scheme, and... It's making stuff up. All right, let's open up a terminal. Sure, you can bring the NRF Connect SDK along in the terminal. It won't hurt anything. And we'll clone in ESP Matter so that we have the files available on the drive at least. We'll open a File Explorer here, and what's in here? Install tools. A README file. Right. I have to hit the bathroom yet again. Must be the coffee that drives me. So just for fun, let's test out a new feature of the stream called Hunt the Kitty. Okay, so you should be able to hear me through the phone now. Alright, so we have both audio from me talking and video. So let's go for a little walk around the lab. There is the 3D printing station. The retro hardware shelf. We have another workbench. With shelves covered in random junk. We have the bar and pool table and we got this giant closet that hides the furnace. And then endless components. This guy is the custom UV oven. Wah. We got a vacuum pump going here. There's a vacuum chamber down there. And it appears to have a container of forgotten resin in it, so maybe we should play with that later. Here's kilograms under here. Where am I? The camera. Alright. Flip you over? No, flip you back over. Alright. This is strontium aluminate powder, a kilogram of it, also known as glow-in-the-dark stuff. We got resin and all kinds of other fun stuff on the counter. And this is curing tape has fallen off of. Oh, well, I'll fix that later. Then we have the Cozy Cave. Hi. Let's get a little retro. So we have our absolutely massive CRT TV.
should let it make the edit before compiling again. I'm just trying to figure out what it's doing. Oh, it found map.h, cool. Pulling it straight to the ESP release. Turn that blinking off. Looks like I spelled blink wrong. Told right. 1% right. Oh. More code errors. It's checking the matter implementations to see what it should actually be doing. Ja, found joy. I'm just going to give permission to edit the INO file whenever it wants, so I don't have to prove it every time. Ah, that was quick. Now it thinks it's rewritten it for the library. Let's try building again. This compile should take a lot longer if it actually gets the matter stuff. Shall I twiddle my thumbs? Warlock is ambiguous. Have some error messages. Hello, Finn. Welcome back. We're still fighting with Cloud, trying to get the matter stuff going because I really don't want to work with ESP idea. Alright. Things like that. The compile should take a bit less time because it's already compiled most of the files in the compile path and it shouldn't have to change much. Fingers crossed. Oh, right. Let me switch voice back.
That should be the correct microphone again. Thank you for letting me know. This camera can go wireless, and I took a walk around the whole basement earlier to show off all the toys and tools and other things. Tokenization is skipped for long lines for performance reasons. What does that mean? What is it tokenizing it for? Alright, this is where it's probably going to fail again. Okay. How long is this? Dear? What the heck? It's like the beginning of Spaceballs where the ship's going by and it just keeps going. Those lines are insanely long. That is not something I would definitely touch by hand. Like, yeah, type that. Alright, it built. Let's flash it. This build should be a lot faster since it already has all build artifacts. It should just be like, oh hey, it's there already. I don't need to do that. We hope. And we're flashing. Nice. Alright. It is... Okay, so... the override works. Let's see if it wants to talk matter. Okay, so hardware state. We're just gonna plug it and plug it back in. Error, matter node not found. What does that mean? Oh. Well, at least it compiles. It forgot to create half the code. Oh, the pun is painful. Thank you, Basil. You know what? The next thing we're going to do for the stream is set up the Discord bot that when I go live, I tell it, hey, post this message about what I'm doing to these channels, and then people actually show up. Probably really help. Because I'm pretty sporadic. I don't actually follow my own schedule. Oh yeah, I should start posting links to my actual Discord. Let me just do that. There's that one, and then... How do I get it over to you? I guess I will open a Twitch window and talk to myself. There is an invite to the Digital Toaster Discord that anyone's welcome to join. There's only like 20 people on there right now, but I figured I'd open it up again to the world and start posting. See that laptop over there? That's Twitch. That's the red site. I guess I'm not allowed to say the names of the services on when I'm double streaming, but whatever. I'm not trying to drive anybody to the other site. I'm trying to let people from both sites be able to see what I'm doing. Alright. Let's see if the updated firmware will have matter functions. I'm liking this one a little better. I didn't stream yesterday because I was so obsessed with getting, like, commercial music going that I eventually gave up. And just didn't stream, so today we get royalty-free techno in the background and we get some freaking work done, right? Because as my friend told me, music is music. So this doesn't have any R. Actually, we have the full RGB here. We have red for the relay, blue for the lock state, I think it's crashed. Oh, no. And green for the unlock state. Here's your light switch rave. I am the cheat. That was fun. And Goofy. Alright, let's see if the AI got the code right. More RGB. That can be achieved. I just need to find 12 volts over here. Oh, here's some volts. Let me light. And there was light. But that's not enough. We need more. Here we go. Big beefy 12. 12. I need a 5 volt supply. Just make sure we read what we're doing first. Yeah, that's 12 volts, 3 amps. Not what I want. We want that later, though. What do we got? What are you? 5 volt, 1.8 amps. That's a bit weak. Next. JL PCB box. Camera wants to come and play. Let's get the balancing act adjusted. Lampshade, calculator, random box of crap. Whoa, what's this beefy boy? Damn, that is a lot of 12 volt. But not what we're looking for. Alright. Oh, that'll come in handy later. Enjoy my partially eaten sandwich while I get another box. And take a quick break to read the chat. Kick and Rumble next. Nah, we don't like Kick. Your PCB didn't arrive. If you have like pictures of the PCB or something, feel free to share a link in the chat. That would be cool to see. Irascible, I'm glad you finally found a Linux you like. Try not to blow it up this time. Right. Next box. Got an old Elgato. Ooh, USB extension. This will let us hook up one of the other lights. This invisible one hanging in the corner here. So that's the W in the RGBW. What am I going to do about this horrific mess, though? I guess we will fight the octopus. I don't see any power adapters in this. Bag of standard power cords, firewire, regular power, Sony 2-pin lobed power, Wii U had power, more power, external Molex power, ancient IBM laptop power. This actually goes on the shelf with the retro laptops. Okay. What do we got? Ooh, this looks promising. 5 volts, 850 milliamps. That's like a fart in the breeze. I'm looking for one of my big, beefy 5 volters. This definitely won't be it. But I think we may end up using this later. This is a cheesy, lightweight 12 volt. At least I think it is. They didn't put a sticker on the damn thing. What does that actually say? 12 volts, 2 amps. Doubtful. Oh, here's a weird one. Void Pictures would be cool. I have a Void Cat, so Void Linux really appeals to me. Though I usually just run whatever the latest Ubuntu stable is, because I don't want to screw around. I just, I'm going to install Node.js on it and not touch it. We got a slightly more modern version of the Molex brick that has serial ATA power on it. This guy looks a little promising. But we'll look at the other oddity I have in hand here in a second. Do I have the cardboard over here? Probably, but... So what we have here is an Ethernet connector. And this goes into a PCMCIA card for an ancient laptop. So this can go over in the retro laptop pile. Easy 12 volter, and then what is this guy? $12-volt, half an amp, with a long cord. That is perfect for this project, because the relay is going to be driving a 12-volt device that requires 0.2 of an amp. So this gives me 0.2 of an amp for running the maglock, and then half an amp, or 0.50 milliamps to run the microcontroller and LEDs. And that's only half of its capacity, so 2x safety factor. Ideal supply for this application. Shit for almost anything else. I'm gonna plug the mobile camera back into power. This isn't like a special... No, this is center positive, and so incredibly common. And the connector looks like crap, so perfect since we're cutting it off. And this is going in the trash. But we're still looking for a 5-volt supply. For more RGB! We'll put the octopus guts back in the box for now. Well, I found 2 more absolutely beast mode 12-volt supplies, but I'm still looking for a 5. Let's take a second to admire this sweet-ass fan. Now, if I wanted a cross breeze on my desk, this might be perfect, so I think this is staying out. So this is a all Noctua.
build of a desk fan. Speaking of buck converters, this is the 12-volt buck converter for this device, which is tuned to run at 5 volts right now. But we're just screwing around with the fan because I have ADHD. So on top, it has... Does it have branding on it? It does, right there. It's got the knock to a text. It has some cool features that I want to show off though. So the controller on the top has speed control and a feature. Oh, unplug it again. Let it spin down. I don't want to stick my finger in there, but no. Alright, stop. So this time when I plug it in, because it was at max, it cranked right up. But I should be able to stop it. So now the blades are stopped. We're going to turn on Noctua's patented anti-stop control. So in a second, it's going to give it a good kick to start it up, and then start PWMing it slowly. There she goes. And you can actually see the blades. It's spinning as slow as it possibly can, and we'll spin it up. And it's putting out a nice breeze. It's pretty much right beside the mic, and I don't know if it's
Causing much of a change. So that's on max. Pretty quiet. So yes, it has a PWM controller built into it, a Noctua branded one. So if I put this here, and then over there where the sandwich is, well, let's just point this down. So fan's over here. We'll replace the sandwich with something a little less edible. Now, we got a blower and a sucker. So if I'm working here, there's a cross breeze. But we're not actually soldering anymore today, so. All right. Onwards with the quest for power adapters. My unending quest for power! Alright. How about this bin? What are you? You are a Stontronics. 5.1 volts, 3.1 amps. Oh yeah. Fuck. It's USB-C. And I need a 12. Oh, right. I'm being dumb. This thing has a buck converter built in that puts it down to 5.
3 amps at 12 volts. Hello, little light controller. So now we have well, it's not RGB currently, but we can do something about that. Let's see if it's on the Wi-Fi yet. All right, we're going to try that again. With the output turned off so it's not, like, killing it. At all, though. Alright, that's better. Hey, and the controller loaded. So we can try and set it to Cylon mode, which doesn't seem to work. Oh, yeah, there it goes. Wow, look at it freeze up. This is very poorly implemented firmware currently. Boop. But Twinkle works because it's random anyway, so you can't tell when it's slow. Okay. Huh. Well, the last time it wrote firmware, it succeeded, so. Hardware side's working. Let's take a look at the software side. We'll go over to where? Huh? Why did it just toggle? And where is my serial monitor? Okay. Now I'm rereading this message. You want to build one with a PWM controller in it. Yeah, definitely. That's what that thing is. They're really nice.
Let's turn the music back on now that we're not playing it listening to fan noises. Alright, let's reflash it with the feature to actually give us the pairing code. What's funny is if Matter doesn't work, this is still a completed project because Matter support wasn't requested. It's just a really nice feature that I'm going to try and surprise the person with. If it works nicely. If not, we go back to hard firmware and they just get what they asked for. Alright, let's clear the console. Capture the full boot message. Alright, we're gonna have to temporarily borrow the camera. See if it shows up on BLE or something. Device. And it wants to scan a QR code for a Matter-enabled device. Well, let's do search for device. Maybe it's maybe it's beaconing. It's looking for nearby powered devices, so it might find something. Probably not. It found my kitchen display. Not what I'm looking for. Alright. Camera back in the clamp. Getting good frame rate still. I think we need the connected home IP package. That should help out. Let's try that again. Hopefully it prints a QR code this time. Oh, this is a matter sample written by an AI from scratch, so chances are shaky. Nope. We just have to wait for connected home IP to finish downloading because it contains all of the Matter code examples that are out there right now in the open source community, and hopefully it can steal some brains out of that. It doesn't need that feature. And we're almost done cloning in the new repo. Oh, that's neat. You can actually see I have 25% of my context remaining until auto-compact, but I can pre-compact. I almost want to do that while I'm waiting, but it just finished. So. I've given it more code to look at that's actually complete and Matter ready, so... And it's looking for INO files when it should be looking for C libraries. This reminds me of the 80s for some reason, this funky beat. Like a Ninja Turtles movie or something. Oh hey, it found a door lock example. This should shortly result in something useful. In the meantime, let's fire up a print job. I downloaded some STLs last night that I'd like to print.
Alright. Allow search of files. Yeah, please. Please search. Yeah, I believe Orca Slicer is actually based on the same parent ancestry as Bamboo Studio. Ah, it found where to get the pairing codes in the Arduino libraries. Now let's get one of the printer views up. Uh-oh. Doesn't that show up in here? I see. Let's re-enable the droid cam. See if I can get that right side up. Nope, it's hopeless. Either way. There is an incredibly glary view of the 3D printer. Sweet. Alright. So, we'll change it off TPU because we'll run the generic PLA profile because it's got clear PLA in it right now. Let's just do a slice and see what setting. Yeah, let's get a better surface pattern. I'm a big fan of concentric. For top and bottom surfaces. That looks kind of cool, I think. Oh, yeah. You see that came with my K1C. But if you want to see something even more toasty, that is a pair of 4-bay filament ovens, essentially.
filament dryers. That didn't work. Just let's check what this is doing. Let's try a build again. My wife actually did a video of just skimming by the filament the other day. Let's put me in front of the filament, though. And... okay. Just do a sanity check. I don't know if I want that infill. Let's go with one of the new ones. PPMS FK. I don't know what that stands for, but it makes this stuff. Yeah, that's gonna print hella fast. So let's compare times. We got 40 minutes with Gyroid. No difference. But let's go to something... where's the worst one? Oh, that would be faster. But definitely not stronger. Looks good to me.